Hello, everybody, and good morning, good evening, good afternoon, and thank you for joining to yet another Neo4j live stream. Today is the topic geospatial data in your graph, and I'm super happy to have you here, Will, my colleague, Will Lyon. Hi, Will, how's it going?
Good. Hey, Alex. Hey, everyone. Good to see you all again today.
Yeah, it's super good, super fun. I think we have a very interesting session today. I'm looking forward to it. I think I said it in the trailer, in the teaser, since geospatial data is sort of a little bit my little pet peeve almost. Like I'm very interested in it. I studied geography back in university days, and
Oh,
so
I didn't know
geospatial
that.
data. Yeah, so geospatial data is super interesting. Something with maps, something obviously very visual, and that I like that a lot. So it's great to see that Neo4j has the capabilities within Cypher to work with geospatial data for quite a while now, and it's gotten better now. And I think your presentation last year at Nodes was another kick in that direction of showcasing what's possible now with the integrations across different systems, different tools. I think you showed something with Python and some visualization tools. And I think that's really interesting. And yeah, I had another guest earlier last year, I think also Veronique Genna, talking about data geographic information systems and how she's using graph algorithms in combination with that. So I think that's a good. It's lots of interest, lots of things going on. So I'm very excited.
Oh, she was doing research with, I think it was like, was it place name ambiguation? And she was using the QGIS Python API to interact with Neo4j, I think. Is that right?
I think that's what it was. Yes. Yeah, exactly.
Yeah.
And then they using the map to overlay that information with the data.
Yeah, totally. Yeah, that was really interesting because I thought, like, I mean, first of all, that research is fascinating, right? Like using graphs for sort of like place name disambiguation. I think it had something to do with like routing for search and rescue kind of things. So they were looking at like different
exactly. That's
mountain
what it was exactly.
geographies.
Find people in the mountain rescue. Exactly. Yeah.
Yeah, and I thought that was interesting because the graph aspect is super interesting of that, but QGIS is one of the most popular open source desktop GIS tooling, and it has a Python API, and Neo4j has a Python driver. So I thought she did a really good job of showing how you can leverage graphs in Neo4j in like the common tooling that you're using in GIS workflows. And that's kind of, as you mentioned, my notes talk from last year, and that was kind of what I wanted to get at with that talk, was sort of showing, here's kind of the standard way of like how GIS works, and you have like an attribute table, and one of the columns in the table is a geometry, and you can do basic spatial operations, but you're missing the powerful aspect of graphs and being able to do what are equivalent of these sort of join operations. If you've ever done joins in a desktop GIS, like in QGIS or in Esri's like ARC platform, it's kind of a pain. It's not very pleasant. It's a lot of button clicking, and I would say it's even worse than doing a join in SQL. So anyway, yeah,
that's the tough one.
Yeah, shots fired, I guess. But
Yeah.
we'll see. That was I guess really like the heart of what I was wanting to get at in that notes talk, was just showing like, here's how you can use graphs in the context of doing geospatial analysis, and we looked at the QGIS Python API in that example. I think the example I used was looking at combining public land data with data from US Congress to see like what legislators are introducing bills, voting on bills, are in committees that have bills dealing with certain public land parcels in the US. And so you can see all the bills connected to like Yellowstone and Glacier National Parks, and kind of get an idea of how those parcels are legislated, which I thought was interesting.
Yeah, absolutely. Now we're already in the discussions. I just wanted to quickly before we fully dive into geospatial data mention Nodes, our online developer conference taking place in October, but the so it's a while in the future. But the call for paper for Nodes ends on June 30th. So you have 8 more days. So basically, this is your last weekend, and then next Friday is where we close registration. So if you have any topic, anything you'd like to present, like to talk about, it can be a lightning talk. Doesn't have to be a full-fledged presentation. Can be something short and sweet. And can totally be about graph data, geospatial data with graphs. So we have 3 kind of themes around the event where we will focusing a little bit on, and they are smart application development, AI and machine learning, and visualization. And I think the latter is a perfect category for everything geospatial. But anything else goes as well. So if you have something else, then don't be shy, don't hesitate, just submit. And it's going to be a fun event. Very good vibes. Like last year, I think we had a great day, and I think this year will be the same. So yeah, it would be great to have your presentations there and maybe submit a session for Nodes.
I love Nodes. It's so fun because people are super excited to share projects that they're working on, things you've built, and sort of behind the scenes. And it's very much focused on practitioners, right? So developers and data scientists.
Absolutely.
And the sort of follow the sun 24-hour pattern that we did. Was last year the first time we did that? I thought that was super fun.
That was the first time we did it, yeah. So that was very good for everybody. I think in terms of attending, you don't have to get up crazy early or super late timings, but you just join when you're in your usual daytime. And I think we're gonna try to do it similarly this time. Maybe not fully 24 hours all the way live because it was a bit much, but it will be the times it will be time zone agnostic. So yes, yeah.
Are we doing? So last year we did these in the weeks leading up to Nodes, like a few workshops that were like 2 or like half-day workshops, kind of leading up to Nodes. Are we doing that again this year?
Yeah, that's totally the plan. So it's a good point. So if you want to do a workshop, there's another category also for submitting. So if you want to present something a little bit more extended, like 2 hours maybe, content-wise, give some hands-on training, some workshop training during a 2-hour block, then you can also do that. And would like to see that submission as well. We will do these ahead of Nodes, exactly similar to last year. Currently, I'm planning to do 4 in the 4 weeks ahead of Nodes, where each week a different topic is covered, and so that would be great to see some submissions from the community as well in this space.
Totally, yeah, and I mean, I think it would be interesting also to hear from the community, like what would you folks like to see workshops on? Like what topics would you like to go a little deeper in? I think we typically cover the basics, right? So like intro to Neo4j, Cypher, and how to do more sort of advanced things with Cypher and those kinds of things. But I think it's a great opportunity to explore new areas and go a little bit deeper. So if you have ideas, let us know in the chat. Like I'd love to understand what folks would like to go deeper on.
Yeah, that's always good. And you can let us know either in chat now, or you do it later in the comments, or tweet us, or pick your poison. Community forums, Discord, wherever. We are always listening. Cool.
Absolutely.
I think that's that with Nodes. So yeah, thank you for that. And I think now we can fully go in the geospatial world of the beautiful geospatial world of maps and graphs.
Totally. So what I thought would be interesting for today, so I've been working on what I've been calling the Spatial Cypher cheat sheet. So it looks like this. Here's the printed version, front and back.
The printout.
I like this format of, kind of taking content and examples, kind of a tutorial, and compressing it into the cheat sheet or reference card, I think is another term for this format. And this is kind of a reference back to school when you were allowed like an index card size thing to take with you to the test, and you'd write, as small as you could to fit all the information on it. So I like that format, and I've been working on a lot of geospatial projects recently, and I thought this was a great opportunity to kind of put together a cheat sheet covering some of the spatial Cypher things we can do with Cypher and Neo4j, and so what I thought we could do today is take a look at the cheat sheet, and there's both a PDF version of it and a blog post. So here's the PDF version. We'll take a look at this, and also just to make it easier to kind of go through things and like copy and paste code and that kind of thing. I also have the same content in the blog post. Let me drop the link in chat. You've already got it. Cool.
Yeah.
Perfect.
Yeah.
Cool.
And it's also in the video description on YouTube. So if you're wondering afterwards when you watch this and think, oh, where's the link? I don't know where the link is. Just expand the little description button on the YouTube video, and there you find all the links, including the ones we talked about earlier, the presentation from Will on nodes, and Veronique's presentation from last year.
Oh, nice. Perfect. You're on top of it. Thanks. What I thought would be fun for today would be just to kind of go through the cheat sheet and talk about what it covers. It's 2 pages, and actually like run the code, and we can find all my typos and things, so I can get that fixed.
That's good.
But
if you have,
of course,
when I think there was, I said in the beginning in the comment section, I said, if you have any comments, any questions, then always let us know. And this obviously applies to everybody. So when you watch this live, we'd like to see what you think about it. And I think I had one comment from a name or not a name, very mysterious. They are prototyping a system with geospatial data. So it's great to see that. And if you are using geospatial data with Cypher at the moment or thinking about it, and you have any questions, any feedback, then type away.
Yeah, totally happy to answer any questions that come up. Otherwise, we'll just sort of take a look at the cheat sheet and the various sort of things we can do with geospatial data.
Yeah, sounds good.
Cool. So let's see. Maybe let's take a look at the PDF version of it first, since I think that looks pretty neat, and then we'll go through and run the code. So let's see if I can get a full screen as possible here. So cool. So the first page kind of introduces Cypher and the property graph model in the context of an airport data set. So I grabbed a data set from the U.S. Department of Transportation flight delays, I think it is. And so what we can pull out of there are the airports and then flights, like actual routes connecting airports. It's focused on delays. So I think it's one year of flights. Every flight that I think these are just commercial flights that the FAA records, and then how late that flight was, if it was on time, if it was 10 minutes late, whatever. And I kind of ignore the delay piece of it, and we're just looking at routes connecting airports. This is a similar data set to what's in Neo4j sandbox for I think it's the default graph data science
exactly.
use case.
Just wanted to say, sounds similar to that one, yeah.
Right. So it's similar to that. That one, I think, covers the full world, though. So because this comes from U.S. Department of Transportation, it's this is a smaller data set, which is U.S. airports. So that's sort of the context of how we introduce some of the features and Cypher. We talk about the native spatial types available in the database, which we'll take a look at in a minute, and then things like spatial search operations, how to do geocoding, a little bit on different ways to import data, both from CSV format or GeoJSON, which is a common format that we see in the geospatial world. And of course, routing is or pathfinding is a pretty common use case when you're working with geospatial data in a graph database, because this is one thing that graph databases are really optimized for, right? Finding the shortest path between airports, looking at intermediate flights in between, and of course there are different things to optimize for when you're looking at pathfinding. So we'll get into that. Then on the back of the cheat sheet, we take a look focused on using Python with Neo4j. And so the first half, we're assuming, okay, you've loaded this flight data from the first half of the sheet, and now we want to use Python to build a geodata frame. So if you're familiar with Python, there's a package called pandas, which introduces a data structure called a data frame, which is like a table. If you're working with geospatial data, there's a data structure called a geodata frame, which builds on top of the pandas data frame to add some basic geospatial functionality. And basically the way that works is there's a column in your data frame that has the geometry, and each row is a feature with some geometry mapped to it that allows you to do the common spatial things like intersections and these sorts of things, depending on what kind of geometry you're working with. So we cover how to query Neo4j to build up this geodata frame and then visualize it in Matplotlib, that kind of thing. Okay. And then the final thing we look at is working with OpenStreetMap data using the OSM-INX Python package for fetching data from OpenStreetMap. And that's it. That's this course is not everything you can do with geospatial data, but it was everything that I could fit in a reasonable sized font on 2 pages.
That's a good. I think it's a great start to help with work with it and get the ball rolling, kind of with the geospatial part of Cypher. It's a comment from Rambo TV. I believe routing is the most useful feature. So much pain to store and read such data from relational databases. I think that's on point.
Yeah, totally. Cool. So let's see. I have Neo4j running. Let's maybe can we do a split screen here? Is that what I want? Yeah, there we go. So I've got Neo4j running. I think there's nothing in here. Let me zoom in a bit and zoom in a bit on this one. So I think we have an empty database. Let's just make sure. So we're just matching on all nodes and returning the count of them. Yep, 0. Nothing in the database. So let's go through and just kind of take a look at how we work with airport data, in this case in Neo4j, and yeah, see what questions come up, and we'll go from there.
Sounds good.
So with Cypher, I'm sure some of you are pretty familiar with Cypher. Some of you are probably Cypher experts. If you're not familiar with Cypher, it's the query language that we use with Neo4j and other graph databases use Cypher as well. The basic idea is that we draw these sort of ASCII art patterns to represent the piece of the graph that we're looking for, or if we want to create data. In this case, this is a match statement. So we're searching for where this pattern exists in the graph. And we draw nodes with parentheses. So like in this statement where I said match A, return count A, this is kind of the most bare bones pattern that you can define in Cypher, which is just a a bare node, right? So A here is a variable that then we use to refer to any piece of the pattern that matches. But we can define much more complex patterns, including specifying the node labels or the properties that exist. So in this example query, we're saying find the airport node with the IATA, which is the like designated 3-letter code for the airport. It's SFO, so San Francisco Airport. And then finds a flight 2. So follow these flight 2 relationships, and it says star 2. That means go up to 2 relationships that you're going to follow to find the path to another airport, RSW. This is Fort Myers, Florida, which is kind of near where my dad lives. So I'm kind of familiar with this route when I go to visit my dad. And you get back something like this. So I can go from San Francisco to Denver, and then from Denver to Fort Myers. And we can see here we're storing properties on the nodes and on the relationships. So if we zoom in a bit, I'll get a little more room here. So we've stored things like the airport code, the city, and then we've stored the location as a point property. And so we'll talk about the point type in Neo4j. That's kind of the base for a lot of the geospatial functionality is this native point type. And then on the relationship, so for every route that some carrier flies connecting airports, we know the distance. And then I've added the number of flights. This is the number of flights per year, at least per, I think it was 2015 or 2016 is the data set that I came from. So there's over 5,000 flights in a year from San Francisco to Denver. So less than 400 from Denver to Fort Myers. So that's maybe like 1 a day or something. Cool. And of course, this is not necessarily the shortest path. We'll talk about routing and things like that in a minute. This is just kind of the first path that we've found in traversing the graph. So I said the spatial point type is kind of the core of a lot of the geospatial functionality in Neo4j. So Neo4j supports either 2D or 3-dimensional points, either using geographic coordinate reference system, so WGS84, which is like latitude and longitude. So your units are decimal degrees, latitude and longitude. Or you can use Cartesian coordinate system, which in that case, this is kind of the units are whatever they mean to you. And we're going to focus on using geographic coordinate reference system. But a reason why you might use Cartesian could be, I know there's some users that have built things like modeling, say like the internals of maybe like a car components or some manufacturing process where you're not talking about like latitude and longitude and some point on the surface of the earth. You're talking about these like physical things in Cartesian space and how these different components fit together. So that might be a reason why you would use the Cartesian point instead of a geographic. It's my understanding that there are not a lot of databases that support 3D points. And this was something that when the spatial functionality was added to Neo4j, there were some specific use cases that users were interested in for supporting 3D, and so that's why we added 3D, which is pretty neat. We're not going to do anything with 3D. We're just looking at the standard sort of latitude and longitude 2D geographic points today. And so I can create a point. So here's how we do that using the point function in Cypher. So here I'm just returning a point object that I've created by specifying latitude and longitude. I could also specify height for this, which would give me a 3D point. Or if I said X and Y, I could specify Cartesian. That's how I would do that. And then of course we can set points as properties. So here we're creating a node for San Francisco airport, and we're setting the location property on the node equal to this point object. Now, when it comes to doing things like spatial search operations, so finding points that are within some radius distance of each other, or within a bounding box, or things like this, we want to use a database index to do that. And there's a specific point index that we can create in Neo4j. And this will allow us to do faster lookups. So rather than scanning and looking at every single node in the database and calculating the distance, we can use an index to do that. This is the actual implementation. This is I think a generalized B plus tree using the Hilbert space filling curve, which is like pretty standard for geospatial indexes. So let's go ahead and create our index.
And that is something we recently introduced, if I remember correctly. I think with version 5, right? Or was the point index available before that?
Yeah. So yeah, good point. So a couple things have changed. So before version 5 of Neo4j, you could create an index on things like numeric values, text string values, point objects, dates, things like this. And behind the scenes, the implementation was a bit different. In version 5, we introduced new index types that are more specific for the type of the property that you're creating the index on. And so now there's an index that's more specific for working with point data. You get a more specific index that's optimized for working with numeric values, string values, and there's a new range index. So if you're doing like range queries, the syntax changed a little bit. So you have to specify that I want, in this case, the point index, and sort of not just a general index on this property, and let the database figure it out. Yeah, that's a good point. And so if you have used the previous syntax, we should find it. There's a page that talks about kind of the syntax in version 4 and previously for things like creating indexes, and then in version 5, the syntax is a little bit different. So you can see here what it looks like for Neo4j 5 going forward.
Yeah.
Cool. So we can do things like radius distance search and bounding box. I'm gonna skip that part and go to our data import, because we don't have any data yet. So let's import our airports and flights, and then we will go back and do some of the search operations. So when we're creating data and importing data in Neo4j, we often want to create these constraints. And so here we're going to create a uniqueness constraint on the airport node that's going to ensure that the airport code IATA property is unique. So we don't want to create any duplicates. I don't want 2 SFO airport nodes. That's going to be very unhelpful. And so creating a constraint will enforce that at the database level, that we won't have any duplicates. And I think I may have already created this constraint, so I think we might get an error here, and that's fine. Yep, since we already have the constraint. So what we can do here is we can say create constraint if not exists. And this way we just don't get the error. If the constraint already exists, then we just don't do anything.
Do you want to do a quick detour question?
Absolutely, yeah.
From chat. So there was like, how do you know about? I mean, we talked about these 3D space locations that are available, as well as the general latitude, longitude, kind of 2D representations of any point on the globe. And Cole Courtney had, together with Marvin, I guess, an interesting comment about how does it work with spherical coordinates or with 3D coordinates in the world. And then Marvin says, if I wanted to map the ocean looking for the Titan submersible, which is currently lost somewhere around the Atlantic Ocean, can I combine latitude, longitude with ocean depth, or does that not work with inconsistent units? Do you know that?
Yeah, so let's talk about the missing submarine first, since that's kind of a fascinating story.
It is.
I haven't heard the latest on this. I don't know if they found him yet, or
I have not. I mean, last time I checked, this was this early morning. I was just looking for it, and didn't look very good in terms of thing. But now, actually, I just refreshed the news page. It said submersive vehicle found debris.
oh.
So if it is indeed, if it is this vehicle or something else, they don't know yet. But it seems like something was found, but it's still unclear.
I was listening to a news story, and they interviewed a journalist who went on that previously, and he was describing it. It sounded terrifying. He said they bolt you in from the outside, so even if the sub is able to surface on its own, people in there can't get out by themselves. It's not very claustrophobic to me. But anyway, to get back to the question, yeah, I don't know how underwater how that's handled. I mean, I kind of feel like they probably switched to some sort of Cartesian reference system where you're sort of just on, sort of X and Y in Cartesian space, or I don't know, maybe latitude and longitude applies as well. I've never looked at underwater data. I know what is that called? Bathymetry is sort of mapping the like underwater surface. But yeah, that's a good question. That's not something that that I'm familiar with. So
yeah, I think latitude and longitude does not take into account the height differences. I think it assumes the globe is a flat surface. So no matter if you are on Mount Everest or in the Mariana Trenches, you're all samey. But maybe there's a way of adding that data in a second layer and combine it somehow, potentially.
Yeah, and so the world of coordinate systems, it's, what is it called? Geodesy, I think, is the area of science which is simply like studying the surface of the Earth. I think is what it is. And there's, of course, all of these ideas of like projected coordinate systems, because you're sort of taking a geoid. It's not the Earth is not a sphere, right? It's kind of like elongated because of, I don't know, gravity or something, and then the Earth's magnetic field is different, and so there are like different sort of like shapes of different pieces of the surface due to the way that the magnetic field is different throughout the different points on the Earth. And so we learn more and more about this, and so over time these coordinate systems are adjusted to take into account that aspect. And then you have the aspect of like projecting coordinates from this geoid surface onto a two-dimensional map, right? And there are different ways to do these projections. And so we'll save that maybe for a more in-depth discussion. But just sort of looking at the basic latitude and longitude, which I think takes into account some specific geoid model of the Earth. And of course, like, none of this is perfect, right? It's sort of modeling our understanding of the Earth. But yeah, this is a pretty rich and complex area to get into, for sure. Cool. So we've created our constraint here, and the next query here, we're going to load the CSV file. Oops. What did I do wrong? I'm going to copy this. So I have a CSV file. There's two different ones we're going to look at. One for, there we go. Let's maybe zoom out a little bit. It's kind of hard to read. So we're loading the CSV file of airports, and then we are iterating over each row, and we're using the merge statement. So we could do a create here, but we may have like airports listed multiple times in the CSV file. So we're using merge, which is like a upsert, like get or create. This will avoid creating duplicates, and merge combined with a constraint. So you can think of like merge as kind of from like the query of the client side saying don't create a duplicate, but then the constraint is the database enforcing that. So we're kind of doubly ensuring we're not creating duplicates. And in the case where we create an airport, we set things like city name, state, country, and then the interesting thing here is our location, which is going to be a point type. We're going to specify latitude and longitude, just casting those to a float from fields in the CSV file. So we have a few hundred airports. The next piece is the flight piece, and so this is going to take a little bit longer, and this is not. I could have sort of combined all of these, but remember this comes from I'll just run this, then we'll talk through what we did here. This comes from Department of Transportation, and so each row, I think there's like tens of millions of rows in the CSV file. I'm not sure how many. It's basically every flight for an entire year is one row in the CSV file. And so I wanted to show how we can work with larger CSV files. So note here that I added this :auto, and let's go back to this width, and then I can zoom in a little bit. Yeah, there we go. So the :auto is something that's kind of like a hint for Neo4j browser or query if we're using Aura. I'm using Neo4j desktop locally, but we could do the same thing with Neo4j Aura, which is Neo4j's cloud service, so managed database in the cloud. But this :auto is just kind of a hint to Neo4j browser that says, hey, I'm going to do something across multiple transactions. So when we're importing data into Neo4j with load CSV, we can sort of do everything in one transaction because Neo4j is a transactional database. So it will build up transaction state in memory and then will attempt to commit transaction all in one go. But if we have a huge CSV file with like tens of millions of rows, we don't want to do that all in one transaction because we'll build up a lot of transaction state in memory. It's going to be inefficient for the database. So instead, we can use this call in transactions syntax. This is a subquery here, and when this is combined with load CSV, what this is going to do is in batches of 100,000, and that might be pushing it a little bit. I mean, maybe this is a little too large. You can kind of tweak this a bit to see kind of what works for the query you're running or your specific configuration. But basically, in batches of 100,000, we're going to find our origin and destination airport, and then we're going to merge on a relationship here. So previously we were merging on the node, and we had a constraint that said, don't create duplicate airports based on this IATA. But now we're merging on this relationship. So if there's a flight to relationship connecting two airports, don't create a duplicate. Instead, we can have kind of control flow logic with merge. So in the case where we're creating this relationship, then we're going to set the number of flights to 0. And because it's the first flight between these two airports that we've seen. actually number, I guess that should be 1, not 0, but that's okay. Then in the case where we've already seen the a flight connecting these two airports, we're going to increment this number of flights counter. And so this is why this took so long. So this took about 2 minutes to run, because we were iterating over and over the same flight that we've seen and like multiple times per day over the course of a year to increment this flight counter. So if we didn't care about incrementing the number of flights, this would have been a lot faster to load. But anyway, I wanted to sort of cover this idea of this call in transactions function. This is new in Neo4j 5. Previously, with load CSV, this would have been called periodic commit
yes,
for a similar functionality.
Yeah. Cool. Yeah, and I guess, I mean, the file is pretty big in itself. So even without the incremental numbers change, importing all the flights between all the different airports across, even though it's only United States, within a year, there's a good amount of flights.
People do a lot of flying. Yeah, for sure.
Yeah.
So cool. We've got so just over 4,500 different flights, the like routes that connect different airports. We've got only 322 airports. So we can look at this in Neo4j browser, see the different flights here. And so this is Kalamazoo to Atlanta. There's only 18 of those per year. Not a common route.
No,
cool.
Maybe not.
So that's CSV import. GeoJSON is another common format where we have a JSON document, a JSON file, and GeoJSON is kind of a specification for how we can add features and geometries with JSON, and we can work with that in Neo4j using APOC load JSON. So this is a different data set. I'm not going to load this one, but here's kind of how this works: is we say call APOC load JSON, point it at the file that will parse our JSON document, and then we have in this case we're calling it value, and in GeoJSON there's a features array. So we're going to iterate over that and create parcels. I think this is a data set of, I think, public land parcels in the US. And one thing that's interesting here, so previously we've been talking about just point geometry, so like a single point, latitude, longitude. But of course, the other two types of geometries that we have are lines and polygons. And so to represent the line geometries or polygon geometries in Neo4j, we can build on top of the point geometry and use lists or arrays of points to represent either a line or a polygon. And so that's what we're doing here. These geometries are polygons, so they're land parcels, right? So like some like parcel of land, and we're storing coordinates as latitude and longitude pairs of points, which in a previous blog post, I think this was in the notes talk that you mentioned earlier, that you linked earlier, we take a look at how you can do spatial search with this. So you can still use an index to find more complex geometries. Here's the spatial search functionality that we skipped over earlier. So like now that we have our airports imported, I can say find an airport where the distance between the airport and between a specific point is less than 20 kilometers. So here the units are meters. And we get San Francisco Airport. If I increase this, let's go to 100 kilometers. Now I'm pulling in like Oakland and Monterey, and I can see the flights between them. I can double click out and sort of see more of the graph. So that's radius distance search, where I'm specifying distance. I can also do bounding box, where I specify a point for the lower left and the upper right, and I can find airports within the bounding box. And it's important to point out, if I pin profile to the beginning of this will show me the query plan.
Mhm.
And I can see here that we're using the index. So we're using our point index that we created to very quickly go through and find that. So like even with the added overhead from profile here, this takes 2 milliseconds to run. It's a small data set, but the idea is, if you had millions of airport nodes or millions of indexed points, it would be much faster than scanning over all of them and computing the distance.
Absolutely.
And
yeah, it's always a great way of. I mean, it's a good best practice anyway to use indexes as much as possible anytime you go for a new or work with a new database. But if you can in Neo4j, obviously use the one that's fitting for your scenario, or use more than one if you have a mix of data. But yeah, if you have wondering about performance, or why something slow, or why something not as quick as you would expect it, check if you have index enabled. You can do that here in the profile. I think you see if it wouldn't be using the index, then you would also be seeing there something is wrong in terms of the setup, and then that's a good way of doing things.
Yeah, exactly. And the thing that we're kind of looking for when we're looking at a query plan is the number of DB hits. That's kind of the number of database operations. And so we kind of want to minimize the number of DB hits that still gives us the answer we're looking for.
Yep.
Cool. So we talked about spatial search. I don't think we did geocoding yet. Geocoding is pretty interesting. So geocoding is basically this idea of taking a description. So here we're saying the SFO airport, taking a description of something and turning that into in this case, a latitude and longitude. And we can do geocoding in Neo4j through the use of APOC. APOC is kind of like the standard library for Cypher. So to add some additional functionality, it's installed by default in most distributions of Neo4j. So in this case, we can use different geocoding servers. So I think by default, this uses OpenStreetMap's Nominatum API for geocoding over OpenStreetMap. But if you have a lot of data, you can configure it to use like the Google Cloud geocoding API that will give you a higher rate limit and sometimes better results. And I think it gives you a bit more information. We can also do reverse geocoding. So if I had a latitude and longitude, I want to know like what address that is, or what description for that place. So here we're looking at SFO airport, but we can search for lots of different things. So if we want San Mateo in general, San Mateo County, other San Mateos throughout the world.
Oh yeah, there are more than one.
yeah, totally.
In Spain, Colombia.
Spain, Colombia, yeah. Oh, is this the Canary? Yeah, Canary Islands, right?
The Canary Islands, yeah.
Cool. Okay, so we talked about import. I'm going to skip over that. We can look at pathfinding. So here's this example that we saw earlier, where we're looking at the path between San Francisco Airport and Fort Myers, Florida. But now I've added shortest path to this. And we get this route. So we go from San Francisco to Charlotte, North Carolina to Fort Myers, Florida. And if we look at this on the map, so here's what this looks like on a map. So San Francisco to this is a slightly different one. This is a different version. But we can see here, like this doesn't seem like it's the shortest path, because I'm going like all the way over here, and then I'm coming back west a little bit on my way down to Florida. So what's going on there is that when we say shortest path, this is a function built into Cypher. This is specifically, Cypher is doing a binary breadth first search. So from both of our in nodes, so San Francisco and Fort Myers, traversing the graph, doing a breadth first search from both ends to find the shortest path as defined by number of relationships or number of nodes that we hit.
Yeah, number of hops. Yeah.
Exactly, and here we've specified, go only search up to 10. We can this asterisk is the variable length path operator. So instead of looking for a direct connection from San Francisco to Fort Myers, which unfortunately there is not a direct flight, I've looked for that many times, you can specify a lower bounds and an upper bound. So I'm saying that 10 flights is my threshold for what I want to look for. But of course, we find one shorter. Yeah. Now, typically what we want with routing and pathfinding is we want what's called the shortest weighted path. And the weights are typically distance, but it could be something like time or monetary cost, whatever that is. And that's the thing that we want to minimize, is the cost of the total path, the total route. And so here we have a couple of options. Dijkstra's algorithm, which is kind of a enhancement, maybe, I guess, to breadth first search, where we prioritize sort of the low cost routes first using a data structure called a priority queue. So sort of as we're doing the breadth first search, we're taking into account basically the sum of the cost, the sum of the weights, in this case distance, and we can see we end up with a much better route. So let's run this, and that's some airport in Texas, Dallas, maybe. I don't know my Texas geography, but let's run this. Yeah, Dallas Fort Worth, and so that's our path. That's much more reasonable. There's also an algorithm called A star, which uses a heuristic to sort of pick which flights are selected first, and the heuristic in this case is like, are we getting closer to our destination? And so we're going to prioritize paths that get us closer to our destination. Like, are we moving in the right direction? And I think A star, where you typically see this are in like video games, when there's some like obstacle, and you're kind of finding a way around the obstacle. You're prioritizing those paths that are getting you just like closer to your destination, rather than just sort of a breadth first search where you're just prioritizing only the shortest sum of the weights, if that makes sense. Yep. But anyway, these algorithms are available in APOC for pathfinding, which is why we're using the APOC version here. But they're also available in the Graph Data Science library. So this is a plugin that adds some additional functionality for graph algorithms. And there are Dijkstra's algorithm, A star, but there are also a number of other pathfinding algorithms that allow you to do a lot more customization or things specific for your use case. So here we're using APOC simply because that's kind of available by default. So it's nice. But if you need sort of more customized pathfinding, definitely take a look at the Graph Data Science plugin that adds a lot more specific functionality. Cool. Cool. Should we take a few questions before we move on, or?
Yeah, I mean, we need to see what we do about timing, and if we potentially do a second episode for the backside of the cheat sheet. There was a question from Kendall, and I think we haven't talked about GeoJSON yet, but this is something we might be talking about in a bit, or as I said, in the next episode. But when importing GeoJSON, does it ignore if the type is a polygon, multi-polygon, etc., and infer the coordinates to build the array of points?
Yeah, so I just kind of like quickly went over this example with GeoJSON and the land parcels, and um, there are a few different ways to do this. What I'm doing here is using an array or a list of points to represent the polygon, and we can do this with the line geometry as well. So that's one way to do it. And there's another blog post that I think is also linked in the show notes, maybe, with the spatial search functionality with Neo4j. This is kind of more in depth on the talk that I gave at Nodes, that has an example of how we can do things like still use the database index to work with more complex geometries. But yeah, that's a good question. That is one thing that's a little more complex to reason about and sort of choose the best case for how you want to work with that. Yeah, great question. So we have a few minutes left. Let me maybe just scroll through and talk about the other half of the cheat sheet, and then I want to do a Bloom demo and like really quick.
Yeah.
Do we
Okay.
do we have a hard stop at the hour? Can we go like 5 minutes over? Or?
No, I think we can go a little bit over. Yeah.
Okay, cool. Okay, cool.
Yeah.
So so that's the front half of the beautiful cheat sheet that we covered. On the back, we have these two sections. So one is focused on, let me scroll up a little bit. Yeah, on using the Neo4j Python driver. So now that we've loaded data into Neo4j, our airport route, we want to query that data using Python, in this case, to create a geodata frame. And so what we're doing here is setting this up in Python. First, we write our airport query, and this is a little complicated, but I wanted to show how we can use Cypher to do things like calculate. In this case, we're doing degree centrality. So we're matching on every flight route. So from every origin to every destination, every flight route. And then we are looking at the degree centrality, which is just the number of relationships connected to a node. So for each airport, we count the number of flights to different airports, but then we sum up the number of flights. So that's weighted degree centrality, I think is what this actually called, because we're summing up the sort of weight, which in this case is just the number of flights between two airports in a year. We're summing that up for our centrality metric. And then it gets a little more complicated because I wanted to show how we can sort of get the geometries out of Neo4j into something that we can read. Now, because these are just points, we could have just grabbed longitude and latitude and had that in this sort of object. We're returning an object here for each airport, or for each flight, rather, for each pair of airports. But there's also a different way to do that using what's called WKT, or the well-known text format. And so we can generate that here for our point geometries. And then the Neo4j Python driver has a toDF function, which generates a data frame from your results. So this is really nice because we just run our Cypher query. We're returning one object for each flight. We call this toDF, and we get a data frame, which is pretty neat. And then I do a little bit of processing here because we want to specify the name of the columns, and then we parse the WKT, that well-known text format, when we create our geodata frame. And now we have a geodata frame. Again, this is kind of a geospatial Python specific data structure that now we can do geospatial operations. We have this geometry column that specifies the geometry. And we did this. We did the WKT both for the point geometry for the latitude and longitude for the origin and destination airport, but we also do a line string, so a line geometry to represent the point connecting. And of course, it's not a geodesic line; it's just like a straight line, but that at least allows us to sort of see the connections between the airports, which we then plot here. And so we're using this is matplotlib to plot this in Python, and we're using those centrality scores to size the airports. It's kind of hard to see because it's kind of fuzzy, but we're specifying the size of the airport based on its degree centrality. And then the relationships are also set using the number of flights. But
so the bigger dot is, the more flights go in there. Is that what it is?
Exactly. Yeah, and it's not just the number of flights, but it's the sort of number of other airports and flights together. So if I'm an airport that connects a bunch, like if I'm a hub, I connect a bunch of other airports. I'm an important node, so I get it. So I'm shown bigger. And again, we'll look at this in Bloom in a second here to do something similar. So that's one aspect. Then the other is working with OpenStreetMap data, and there are lots of ways to work with OpenStreetMap data in Neo4j. I like to use this Python package called OSMNX because it will simplify the graph topology for us rather than representing. So in the OpenStreetMap data model, I've got like a point for everywhere along the road, but here we're just sort of representing intersections. And then we can use Cypher to iterate over these geodata frames. So here we're searching for the Boston road network, and we get back a network X object. That's where the NX piece, so OSM for OpenStreetMap, NX for network X, which is a Python package for working with graphs and networks. But we can also get a geodata frame, and this is kind of the opposite version of what we just did. Now we're iterating over the geodata frame to load data into Neo4j. This is similar to what we did this was a couple months ago, March, maybe. I don't remember exactly when this was. We did the workshop on building a routing app with Neo4j and OpenStreetMap, and we used a similar approach there.
We did that in, I'll link to that. That's a good point. We did that, I think, in March.
Yeah, cool. And so, so then I have this fun image here. So this is created with Neo4j Bloom, which is a Neo4j tool for graph visualization and exploring. And what we did here was we ran some graph algorithms using the Bloom integration for the Neo4j Graph Data Science library to find important intersections. So the node size is scaled by betweenness centrality. And so in this case, it's going to be intersections that connect different like segments of the graph. And Boston is really interesting. I don't really know much about the layout of Boston, but you can see here that there are like some pretty distinct clusters or neighborhoods. And so these are colored by, I think we did the Louvain community detection algorithm, does a pretty good job of identifying sort of different clusters in the graph. I'd be curious to sort of see this overlaid on like the neighborhoods of Boston to see how good of a job it does at defining the neighborhoods. But let's jump to Bloom really quick, and in just a couple of minutes that we have left, and we can do the same thing for our airports, because I think this is really neat. And tell me when we need to drop off, because I know we're over time here.
Let's do a few more minutes. Do a quick overview, and then I think we should be good.
Cool. So this is Bloom. I'm using it in Neo4j Desktop, and here I'm just grabbing all of the flights in my data set. So there's going to be lots of relationships. There's only a few hundred nodes, but what's going to be apparent here is the number of relationships that we're going to have to see. And so we get kind of like a little bit of a hairball here with the four-space layout, but because we have geospatial data, we can switch to the coordinate layout that uses the location property And so here we can see how these are laid out geographically.
You can
and so
almost guess already, right? Well, I mean, if you know, then you know. But if you wouldn't know, probably it would be difficult to say. But now that you know that this is the United States of America, you can kind of see that it sort of is the shape of the country.
Yeah. So here's Seattle. This is probably Hawaii. Here's Alaska. Is this like Puerto Rico,
I guess.
maybe?
Yeah.
Florida down here.
Yeah, Florida.
So
yeah, Texas.
Exactly. So this is the coordinate layout, which in Bloom we'll use if you have a location point property, we'll use that for the layout instead of force directed.
Yep.
So this is cool, but we can
There's a new feature also, by the way, which was introduced to Bloom a couple of months ago.
Totally, yeah. And I think this is super powerful when we combine this with the Graph Data Science plugin for Bloom. So here I'm going to calculate betweenness centrality. We'll do this on just our airports. That's the only data we have. So here, betweenness centrality is a measure of basically how how interconnected is a node to other clusters in the graph. And so like the context here would be airport hubs. And so I ran the algorithm just by clicking a couple buttons, and I toggled this rule-based styling. And if we go to the styling configuration here for size, we can tweak this a little bit. I like to go to the extremes. And so for the small ones, make them really small, and for the higher values, make them bigger. But now what this means is that the node size is now relative to the betweenness centrality for the airport. So the hubs are bigger. So that allows us to see airports that connect a lot of different airports. This is different than the degree centrality that we did earlier, which is kind of just looking at like the number of flights and the number of airports. Here, we're looking at actually connecting different pieces, different segments of the graph. Let's style our relationship too. These are kind of getting in the way here. We'll add a rule-based styling on, let's do number of flights. We're going to do range-based for size, and go to the extremes. The small ones will make real small. The big ones will make thicker. So that's a little bit better. We can now see that for segments that have many flights connecting them, the relationships are bigger. It makes it a little easier to see. The other thing I want to do, I'm going to do one more algorithm, and we'll do, I think Louvain typically works pretty good, which is a community detection algorithm. So now we're going to segment the graph by communities using Louvain algorithm, and we can kind of see here the sort of regional segments that appear. I'd be curious to see how this exactly. I'd be curious to see how this maps to the carrier. I don't know. I should have included the airline as well, and we could see if this actually maps to, because I know, like, for example, Denver is a hub for United. Atlanta, I think, is the hub for, is that Delta or something like that? I don't know my airlines very well, I guess, but anyway,
I think it's Delta,
we can see how we can use this coordinate layout in Bloom with the Graph Data Science plugin in Bloom. Is super powerful. The airport one is I don't know, fairly obvious. I think the OpenStreetMap road network ones are a lot more interesting. I went through kind of a fun couple of days with posting these visualizations for different cities on Twitter and asking if folks could recognize what city it was. And when folks guessed the wrong one, I would actually generate the one for that city, which is how I realized that the Boston one is actually quite interesting. Anyway, so that's like a super quick overview of the Spatial Cypher cheat sheet. All the code is in the blog post or the PDF version. There's a few more resources linked at the bottom here. But yeah, let me know if that's a useful format. I like the cheat sheet format. It was fun to put together. I got to test my Illustrator skills, which are pretty minimal. So it's good exercise for me. But yeah, let us know if you think that's a useful format, or if there are other topics you'd like to see a cheat sheet for.
Yeah,
I don't know.
that's super helpful. By the way, Elaine confirmed Atlanta is the Delta hub, so I think you were right with that one.
Cool.
And Elaine also asked, what is Bloom? So I think we kind of assumed that everybody knows what Bloom is, but indeed, Bloom is the visualization tool that we have launched a couple of years ago now to help out users to use Neo4j or use graphs, obviously Neo4j in a more visual way. It's almost like a no to low code approach to work with the data, but also as a visualization aid, because inside browser you have some visualization capabilities, but it's very limited, especially when the numbers go up and you want to showcase a little bit more nodes and edges. I think something like this wouldn't be really possible inside browser anymore. It's even that is too much for it. It's more like a few nodes to double check on your queries. But if you want to showcase something more, then go for Bloom or go something else. And and Paul says it's great to see how many more features have been added to Bloom. So yeah, if you have not looked at it in a while, then lots has happened. Besides the geospatial layout, which we showed here, also the data science, graph data science features, which have been added as well, integrated into Bloom. Some other features like a data slicer, which we didn't show today, but if you look at a couple of our other videos, particularly what I did with Michael on AuraDB, you see lots of the new tools and the new features from Bloom there. As we try to highlight them as they were available. So yeah, it's super interesting.
Yeah, and I think one of the core features of Bloom is not having to know Cypher. So there's this sort of like natural language search that we kind of skipped over because our graph is so simple. We just grabbed all of the flights, but you can kind of start typing what you're looking for as you would think of it, like airport name, SFO, and sort of fills in the pattern for you. But you can do lots of more complex configurations with things like search phrases, where if you're an advanced user, you can specify a complex Cypher query with some parameters that then is made available to other users as part of the natural language search. They fill in the parameters. So it could be like a routing query that's using Dijkstra behind the scenes, but then all the end user has to do is just type the two airports they're looking for and say like route between these. It's pretty configurable for power users. Yeah, it's a really cool tool.
Yeah. Absolutely. Yeah, and if it comes to Cypher, to Cypher in particular, but also to cheat sheets in general, I guess, let us know in the comments. Let Will know on I don't know, do you allow comments on your blog, but at least on Twitter and or LinkedIn, if you think this is great. I think I saw a lot of positive comments here in chat, flyby, so lots of praise for this cheat sheet in particular. So I think that's super good to see. And yeah, if there's other topics that need a cheat sheet, then give us a ping, and we can look into it and think about what cheat sheet to do next, I guess.
Yeah, totally. Maybe my goal should be to make enough of these printed out to fill the wall behind me. Maybe that's that's a good goal for the year, perhaps.
Yeah, that's good. And then next year we do a little booklet, cheat sheet booklet.
Oh yeah, that's a good idea. I like this. I like that.
I think with that we unfortunately we had, well, not unfortunately, but I think sorry for taking a little bit longer, but I think this topic is vast, as you could see, and lots of things we didn't cover yet, but I think it's a good start. And yeah, we would be so happy if you tell us something you did something with the cheat sheet, if you worked with geospatial data now and did something cool, let us know. Even if you don't want to present it at Notes, you can still let us know either some wherever else. If you want to continue the conversation, best places to go is obviously the community forum or our Discord server. There you find lots of people from the community. You can bounce ideas back and forth, or share your projects, share some questions, or answer some questions from the community there. So I think that would be great next places. In terms of live stream content, so it would be great if you could subscribe or like, or both, ideally, the content on YouTube to give it a thumbs up, and so we know you liked it. And we will be back with more content in this kind of vein. The next stream we'll be doing will be on Monday afternoon. Michael and I will talk about another set of data with AuraDB in particular. And I think we're going to talk about nicknames. So something with ChatGPT, nicknames, and graphs. So if you're fun looking at that, join our stream on Monday afternoon. And yeah, with that, from my side, thank you all for watching. Thank you for participating. Thank you for the good chat today. And obviously, thank you very much, Will, for presenting the cheat sheet and for putting it together in the first place.
Cool. Yeah. Thanks for hosting, Alex. And thanks to everyone joining today. And yeah, I hope everyone has a good, well, we're going into a long weekend with Midsummer holiday tomorrow,
oh, yes.
which is a Neo4j holiday, since you have our Swedish origins.
Swedish,
so
yes.
if you're celebrating Midsummer as I will be, have a great weekend.
Yep. I will be celebrating as well. Have a great weekend, everybody, and see you soon on another video. Take care, and yeah, bye-bye.
Bye-bye.